Hey, Red Knights, this is a short explanation of the natural selection simulation that I ran to collect some data for you. So, natural selection is one of the mechanisms of evolution. And evolution, probably one of the best ideas ever in science, really was the question that Charles Darwin came up with on his voyage of the Beagle back in the 19th century, the middle 19th century, early middle 19th century. And so he came up with the idea that natural selection happens because of three big ideas. Number one, there's variability in a population, which means not all organisms are the same. So within us, we have variability of hair color, eye color, height, skin, fingerprints, whatever, that those variations are heritable, which you can pass from one generation to the next. And then there's differential reproduction. So this activity that I did as a paper pencil simulation looks at all three of those things: variability, heritability, and differential reproduction. And I'll talk about that here right now. So basically I had a grid, a 5x5 grid, and I had a population of organisms that I randomized when I threw them on the grid. And so instead of like rolling a dice, this is a random number table that has the coordinates, the 5x5 coordinates on there. And basically I just went down the rows or diagonally or whatever, and then I placed organisms onto this grid. And so this is kind of their habitat, if you want to think about it. So we had predators that were yellow, and predators you're going to see in the simulation had two numbers. They had a generational number, so down in the bottom right hand corner, and I went through 10 generations of this simulation, and 6 for this predator was how well it saw. So it's visual acuity. So can it see really well? Well, it can see better than the 5, which is the pink, and that's the prey. So the prey has a camouflage number. So the greater the number, the greater the camouflage. The greater the number, the greater the visual acuity. And so I did this random number table, and I scattered the predators all over the grid. And then I went down the numbers, and I scattered the prey. So that's what it looked like. And so I did this 10 different times for 10 different generations of organisms. And so basically the way it works here's a sample of what I did one time. So you'll see in each square there's one or two or sometimes none, and it was just random. And so if we look at you can see that some numbers are bigger than others, and that's kind of the way it is. This has my video started? I hope it has. Oh, no, it has. I'm going to wait for it to start. So So you can see I have the green in this case, which is the predator, and yellow is the prey in my example. So it's a 5 versus a 3. Well, a 5 can eat the 3. All right. So now there's going to be some variability, and so the predators.
My apologies. I couldn't hear what you said.
That's okay, Siri. I'm not talking to you. The predators are going to increase by one better and one less. So you can see that one turns into an 10, turns into an 11 and a 9. Here's an 8. 8 can be the 7. So an 8's going to turn into a 9 and a 9 and a 7. Notice it has different generation numbers, and then I take the prey off. Now these two happen to be the same, 6 and 6. I flipped a coin depending on how I did that. Here's an 8. 8's going to be replaced with a 9 and a 7. These were now the prey are reproducing. And so the same thing happened with that. And so I did this 10 different times. If they tied and I flipped a coin, so back to those 6s, then it was replaced with a 7 and a 5. So you can see that the generations wind up with, they're just a little bit better or a little bit worse. And so there's that randomness and the heritability of it. So after every generation, I recorded the average score, how many were alive. And that's the numbers that you're going to see in the data tables that I'm going to share with you. So that's how I did the natural selection simulation. So natural selection relies on three things: variability within the population. So in these populations, we started out with 16 organisms, and they had some with not really good scores and some with really good scores, and a bunch of some that were right in the middle. You're going to see that on the data tables. That that there was differential reproduction, which means there was some randomness involved. And so this is a random number simulation that determined where those predators and prey wound up being thrown onto that 5x5 grid. And then heritability, the traits, the visual acuity, how well they see, and their camouflage had to be inheritable trait. And so that's how this simulation works. So I hope that helps understand how it worked.